The main goal of what we're going to figure out how to do in the next hour or so is to figure out how to deal with not one linear equation, not one line on a graph, but two. And really the question we're asking is, how do I solve two linear equations at the same time and get the same solution for both of them? That's really the main goal for today. So we're going to look at this from an algebraic perspective in particular, so how to do this by pushing symbols around, but along the way we're also going to look at it from the graphical perspective. What does this actually look like when you look at it on graphs? So we're going to back into it pretty gently by posing this rhetorical question. Is it possible, do you think, for two numbers to have a difference of 8 and a sum of 1 at the same time? So these two numbers will be 8 units apart, and when we add them together, their sum is equal to 1. So what do you think? Get your answer into that box, and then we'll see. All right, it certainly seems like people believe that this is possible, right? That there is a pair of numbers that have a difference of 8 and a sum of 1. So I'm going to agree with you. Yes, submit. Okay, so on the next screen, let's find out. So now here's your chance to think about two numbers that have a difference of 8. You can think of any two numbers that have a difference of 8. Get those down and write down the larger of those two numbers in this blank and submit it. So you submitted the bigger number of your two, and you said it was I said it was 7, for example. But now on this screen, the system is asking you, is the other one of your two numbers, well, in my case, -1? Okay. So you were thinking of two numbers that had a difference of 8, and you told us what the first one was, but now this thing automatically knew what your second one was. How do you think it knows? So once you told the computer what the larger of your two numbers was, it already knew what the smaller of the two numbers had to be. How did it know? Brittany says it did the math, right? There was another response up here that was up there a second ago that disappeared. Chris, you changed your answer. Can you change it back? So not only did the computer do the math, but Chris's observation is there's only one possibility for what it can be, right? If I choose, let's say 12, I'm going to pick on Joe's answer here. If I picked 12 for my bigger number, then because the computer knew that your two numbers had to be a difference of 8 apart, and 12 is the bigger one, then that meant that 4 had to be the smaller one. But there's only one possibility. How? Just by subtracting 8 from 12, right? So as soon as I know one of your numbers, I automatically can figure out what the other one is by doing that math. Right? So that's meaningful in this process. So the next step is to take those numbers and plot them as a coordinate pair. So the number that you chose for the smaller of the two, the number that you chose for the bigger of the two, the question I want you to speculate on is, this is my point, this orange point, but your point's going to be somewhere else, and everyone else's point is going to be somewhere else. If we plot all of those points, what do you think that graph is going to look like? All right, so I see some themes emerging in your predictions. If we were to plot everybody's pair of numbers as a point in our coordinate system, some things that a few of you were saying was that, well, a lot of them are going to be close together, right? So Jackie and Greg are both thinking that probably a lot of us chose numbers that are kind of close to one another. We probably did. I mean, anytime we play that game of, think of a number from 1 to 100, most people tend to choose numbers that are kind of close together, right? Also, Joe is predicting that all the points are going to be on the right-hand side of the coordinate system. You're probably right about that, because chances are when you tell somebody to just pick a pair of numbers, most people don't immediately reach for the negatives. Most people are reaching for positive examples. So yeah, probably all the points are going to be on the right-hand side of the graph. Mark thinks it's a mess. A concentration of points, so that gets to the grouping idea that Greg and Jackie were talking about. But there's another thing that's coming out of the predictions here. So Spencer predicts it's a line with a positive slope. Keishel says a line. Brittany says a diagonal line with a negative slope. Interesting. So we have, in those three responses, all agree, or at least are making a prediction that we're going to see a straight line. Of course, I probably gave that away with the title of today's class, right? Systems of linear equations. Probably will be a line, but what direction that line goes is up for some debate. So Brittany takes the position that the line has a negative slope. Spencer says positive slope, and Keishel just says a line. So you're good either way, whichever way it goes. But let's find out. So if we actually do plot everyone's points, let's see what they look like. Uh-huh. Interesting. So I think that this is showing Greg's point in orange and everyone else's points in blue. I think that's true, because if I scroll through, yeah, if I scroll through, we're seeing the same, kind of the same list. Okay, so what part of the prediction came true? They're linear, yeah. All these points are arranged along a straight line. So it definitely is a line. Now let's make a decision on that slope idea. So is the slope of that line that I just drew positive or negative? Positive. And how do we know that the slope of this line that I just drew is positive? Yeah, exactly. That was one of the big takeaways from Monday. Because this graph is increasing from left to right, that means its slope is a positive number. Cool. Great. So all of these points are arranged along a line with a positive slope. And so now your question is, how come? Why is it that all these points are lined up so neatly? Is that an accident? So why are those dots all arranged in such a nice pattern? So Brittany says there's a pattern and that 8 is the slope of that pattern. A couple people are saying that they're arranged in such a way because what they all share in common is that those x and y coordinates all have a difference of 8. They're lined up neatly because they all have a difference of 8. So that's come up here in a few places. Let me scroll down to the bottom. Because it's a linear system. So now you're really trying to look ahead. It's not a system exactly. It's only one equation, but it is linear. And the greater of the two numbers has to be within that group. All linear. Okay, great. Let me go up here to... So I'm going to pick up on Joe, your response. All these points are lined up neatly because they all have a difference of 8. Yes. So what I'd like to do before we move on into the next step, all the points are lined up neatly because each of the pairs have a difference of 8. Now, when you say the word difference, what arithmetic operation are we talking about? Subtraction. And x was the first of our two numbers that we chose, and so x was also the larger of the two. Right, so I'll put x here. X is the larger of the two numbers, and y is the smaller of the two numbers. And based on what we know about x and y, what is x minus y going to equal?
1.
So what all of our xy pairs have in common is that when I subtract the y from the x, I always get 8. That's true for my pair, it's true for your pair, it's true for your pair, it's true for your pair, it's true for everybody's pair. Right? So that's what all of those have in common, is that their x and y coordinates all satisfy this same equation. X minus y is equal to 8. And so, sure enough, if we graph the line whose equation is x minus y is equal to 8, we do get this line. And that line happened to have our points that we all chose lying on it. So my point 7 comma negative 1 was right here. Joe's point 12 comma 4 is right here. And so on and so on. So all the xy pairs that we chose were just different points that all lie along this common line. Before we go forward any further than this, though, I want to understand why this equation actually tells us a line at all. Can we rearrange this equation to get it into the format that we're accustomed to? The format that we're accustomed to right now is the format y equals mx plus b. So how could I rearrange this equation to re-express it in a form that looks more like y equals mx plus b? What should I do to both sides of this equation that will get y to be more by itself? Right now y is on the same side as x. So what can I do to try to get this x away from y? Yeah, let's just subtract it. If I subtract x from the left side, then I also have to subtract it from the right side. Right? And once I've done that, on the right-hand side, I'm going to get 8 minus x. Meanwhile, on the left-hand side, I have a y, but I also have, don't forget, this little minus sign that's in front of the y. So we're not quite done. Now what do I need to do to get the y by itself? Don't forget that when you see a minus sign all by itself in front of a quantity, What that really means is it really means negative 1 times that quantity. Right? So minus y is the same as negative 1 times y, which tells us that in order to get rid of that, we should divide by negative 1. And I'm going to do that on both sides. Then I'm going to have y all alone, but now both of the terms in 8 minus x are going to get divided by negative 1 by the distributive property of multiplication over addition. So 8 divided by negative 1 is going to give me negative 8. And what's minus x divided by minus 1 going to give me?
X.
Yeah, just plus x. Exactly. All right, and now we're almost done. The only last step I'm going to do is I'm going to try and rearrange it so that my x term comes first and my constant term comes second, just to make it exactly match our template. And so for that, all I'll do is just turn around this addition so that my x comes first and my negative 8 comes second. We can do that because addition is commutative. It doesn't care which order we add the two terms in. So now is a good time for me to ask, what is the slope of this line that we just found? Yeah, how do you know it's 1? Yeah, exactly. The slope is, once we've written it in y equals mx plus b format, the slope is the coefficient of x. But this x doesn't have a written coefficient in front of it, and so that hidden coefficient is 1. So the slope of this line is 1. What does this negative 8 right here tell us? It tells us the y-intercept, which we can verify looking at the graph that we have over on the right. Y-intercept is negative 8 is the y-coordinate, and of course 0 is the x-coordinate, because that's true of a y-intercept by definition. So that negative 8 is right there. That's the point at which this graph crosses the y-axis.